Overfitting and pruning. You build a decision tree. It gets 100% accuracy on training data. Every single example classified perfectly. Sounds amazing, right? Actually, it is a red flag. A perfect tree on training data is usually a terrible tree on new data. This is overfitting, the most important problem to understand in all of machine learning. And today we will also learn how to fix it. Here is what happens if you let a decision tree grow without any limits. It keeps splitting until every single leaf is pure. It has memorized the training set, including all the noise and quirks specific to that particular sample. It has not learned the real pattern. It has learned the specific data. Let us watch this play out. As we increase tree depth, training accuracy climbs steadily. Eventually it hits 100%. But test accuracy tells a different story. It rises at first, peaks at some moderate depth, then starts to fall. That gap between training accuracy going up and test accuracy going down, that is the signature of overfitting. Think of it like a student preparing for an exam. One student memorizes every answer from last year's paper, word for word. Another student understands the underlying concepts, same questions. The memorizer looks like a genius. Change the questions even slightly. The memorizer is lost. The concept learner adapts just fine. A deep decision tree is the memorizer. We want the concept learner. How do you spot overfitting in practice? Two classic signs. First, training accuracy is very high, often near perfect. Second, test accuracy is noticeably lower. When you see a big gap between those two numbers, your model is overfitting. It has learned things about the training data that do not generalize. The first fix is pre-pruning. Stop the tree from growing too deep in the first place. Set a maximum depth. Require a minimum number of samples before a node can split. Require a minimum number of samples in each leaf. If any condition fails, that node becomes a leaf. Simple. Fast. Prevents the tree from chasing noise. The second approach is post-pruning. Grow the full tree first, let it overfit, then walk back up and remove branches that do not help on validation data. The idea is simple. If removing a subtree does not hurt validation accuracy, that subtree was just memorizing noise, cut it. The most popular post-pruning method is cost complexity pruning. It adds a penalty for complexity. The objective is minimize error plus alpha times the number of leaves. Small alpha keeps bigger trees. Large alpha favors simpler ones. You pick alpha using cross-validation. Try a range of values. Pick the one with the best average validation score. Scikit-learn calls this parameter CCP alpha. To recap, unconstrained trees overfit by memorizing training data. You spot it when training accuracy is high, but test accuracy suffers. Pre-pruning stops growth early with depth and sample limits. Post-pruning grows first, then trims weak branches. Cost complexity pruning with cross-validated alpha is the gold standard. Next up, we will put all of this into practice with real code in sklearn.